Here's lesson 113, number 2. So it says the half-life of the stuff was 14 years. They started with 10,000. How long will it be until there's 4,000 of them left? So it kind of looks like they're, whatever it is, well, it's decaying, right? It's so when we solve for k, we will expect it to be negative. Half-life is 14 years. So I can say, I can say that they started out with 10,000. I could put 10,000 there, and then I could put a 14 in for time, and I could put half of 10,000, which is 5,000 over here. But I'm going to end up dividing both sides, trying to get e by itself. I'm going to divide both sides by 10,000 anyway, so what's going to happen is we're just going to end up with a half over here. And that's how it always is with half-life. You're just going to end up with a half over here. It doesn't matter, it does matter what you started with because we're going to need that later, but you don't have to use it right now because we just know that there's going to be half of whatever that was is going to be left after a certain amount of time. And we know what that time is. It's 14. So it's kind of going to be like this. We're just trying to find out what k is. Then once we get k, we'll have a sub 1 and k, and we can plug some things in and we'll find out how long for 4,000 to be left. So I'm trying to solve for k, so I'm going to ln both sides, or natural log both sides. Okay, ln of a half is just some fraction or some decimal that I'll just put that in my calculator. ln e is 1, but now that allows me to take use that log law that says the 14k can come down out front, and so that gets my 14k down out of the exponent. Now I can divide both sides by 14, and then I get that k is whatever my calculator says ln of 1/2 divided by 14 is. So let's see what that is. My good calculator that I love. ln 0.5 divided by 14. I got this number on my calculator. A very good calculator. I highly recommend this calculator. Minus 0.0495111. That's how your math book rounded it like that. They took this whole 5, made the 0 go up. They just rounded it like that. I like to keep it in my calculator if I can, but a lot of times I lose it and then I just end up retyping it in. So there's k. So now we know what k is. We know what we started with. We want to know how long it's going to take for there to be 4,000 of whatever this stuff is left. So I think I'll start like this. I'll say 4,000 equals a sub 1, because remember this is this is how you can solve these things. So the amount at a certain time is going to be 4,000. We're going to find out what time that is in a second. So a sub 1 is 10,000. E, we know what k is. K is negative 0.049511 t, right? So we want to solve for t. So just divide both sides by 10,000. So that's going to give e to the negative 4/10. That's 2/5. Well, I don't know. It's 4/10. It's 0.4, I guess you could say. Hopefully I don't mess that up. I'm going to ln both sides to get t down. So this can all come down using the log law, and the ln e goes away because it's equal to 1. Now I have to divide to get t by itself. If I really am going to keep this number, in my calculator, which I don't know if I'm going to or not. I could have just been writing K. I didn't have to keep writing this number over and over, but I thought it might help you to understand what I'm doing, I guess. There, that goes away. And if I didn't make any mistakes, that putting that in my calculator ought to get me the time that I'm looking for. So I guess if I push... Oh no, okay, so see, I knew I would lose it. Okay, so ln 0.4. I ended up having to type it in anyway. Divided by 0.0455. This will actually round exactly to how the book does it anyway, because the book has rounded it to that decimal. So, and that's actually right. So the way they round it is they say it's about 18.51 years. If you can read that, it says 18.51 years. That's approximately the time it'll take for there to be 4,000 of whatever it is left.